Hey guys, I will, guys, I'll try to allow you time to get this. I'll break the break there, but I have to do the whole thing here. Okay, couple of things just for, just to clarify. Second semester of this class is great and slightly repetitive in a good way. What I mean by that is, there's usually plenty of practice to be able to master something before you take the test. You'll start to see that topics build on each other in a way that you'll be able to go on your prior knowledge from first semester. All of the confidence in the world that you'll be totally fine. This does not get any harder, is what I'm trying to say. It evens out over second semester, so the difficulty level of this chapter is the same as chapter 7 and 6. So that. But just because you're in second semester, I'm saying it doesn't get any harder. That doesn't mean there's not new stuff to learn. The entire second semester is about the same topic. It's about taking a sample and using that sample to estimate some stuff about the population. Isn't that exactly what we've been doing the whole year? Yeah, except for that now we're actually going to take a sample and make calculations to estimate something about a population. So we're not going to pretend we're doing it and actually do it with real studies and numbers and things. We will be covering the entire back half of the formula sheet. I will be letting you put a few things on your formula sheet through the course of the chapter to help you. But remember, that's now the only thing that you guys get to have. So I'm going to let you know very clearly a couple of things you need to memorize. One of them I'm concerned about, the other one I'm not. I'm just concerned about, meaning like it's one of those sentences. So, and it actually we learned it today, so there's lots of time to memorize it. Anyway, it's not hard. It's just a dumb sentence, and you know how the dumb sentences are. And I'm giving you all kinds of notes, like 3 weeks notice. Okay. Anyway, so this is kind of strange. Usually, if I give you guys my joke, I do it at the end, but today I'm going to do it at the beginning because it's kind of a teaching joke. So, if you guys will bear with me for a moment, hold on, let me not have Aries come up on the screen. That'd be great. That would be like a first day back in the second semester kind of move. Okay. So, here are our objectives, and none of these things are gonna sound like they make any sense right now, but this is one of the sentences, the bolded word interval, and then this is the other sentence, that's the bolded word level. And it's gonna be my job in the next 3 weeks to make sure that you know the difference between those two things and know which sentence goes with which. And those are really the only two sentences for the whole chapter. So this chapter is not loaded with sentences. This one, you're gonna write so many times that you're gonna say it in your sleep. This is the one where you're gonna actually have to make an effort to practice it. So, as I'm saying, that's the only one. I'm just giving you lots of heads up notice about this one sentence. Okay. So here's my joke, but it's a learning joke. It's Garfield, and he's watching the weatherman, and it says, taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. Okay. And then he says, this guy's never wrong. Okay. So the weatherman is using a very wide interval of plausible values for the temperature, which means that he's probably 100% confident that the temperature is going to be somewhere between 40 below zero and 200 above zero. Okay, I want you to sort of just remember that as, you know, a very wide estimate of plausible values for the temperature. What do you think today's going to be? I think it was actually not that cold this morning. It wasn't bad. I don't know.
But I don't know if you looked later in the week, it's going to get drier but colder. I don't know how you feel about any of that. Mr. Talbot hates it all. So, okay. All right, so let's do some definitions just to get us all on the same page. A point estimator is a statistic. Great, that's the class we're in. That provides an estimate of a population parameter. Okay, a point estimated is a statistic that you get from a sample, like doing a survey or doing an experiment or something, and you use that number to estimate something about the population parameter. Mrs. Talbot, haven't you said that about 47 times already in the first day? Yeah, that's because that's what this whole class is about. Okay, there are 2-point estimators we are going to study in the second semester. We're only doing one of them in this chapter, but for the whole second semester, there's 2 of them. You should recognize these. P, estimated by P hat. What do you think about P hat?
Calculating p-values.
No, that's not it. That's not it. Don't. You have to download that. No. And then mu estimated by X bar. Okay, let's stop here. For some reason, this was one of the most challenging bits of chapter 7. I'm not sure why. You guys can tell me, but this was really, really like that little tiny bit right there was really, really confusing for people. Okay, so P, just by himself, plain old little p, is the population proportion, which is estimated by P hat, which is the sample proportion. So population, everybody, estimated by the little sample proportion. And the hat number means covering your butt, so estimated. Okay, mu means population mean, the mean of everything is estimated by X bar, which is the sample mean. So the thing is, you're probably never going to know these in real life. You wouldn't. Why would you do statistics on something when you could actually get the real number? Does that make sense? Like, these are unknown values usually. And you're going to estimate them by what you get from your sample because you're too lazy to ask everyone or sample everyone. Is that better? I'm hoping. Okay. In this chapter, we're just going to do P and P hat. So there won't be all of those floating around to be confusing. I'm hoping that will help. Okay. Confidence interval. This is the thing I was talking about with Garfield. Confidence interval is an interval of plausible values for a population parameter based on sample data. Okay. Let me write that. I'm going to highlight this just for me. You can highlight that too if you want, if you're a highlighting type person. Okay, so what I'm suggesting is you go out and take a temperature or a random sample of days of temperature. And you do some maths, of which I'm not teaching you today. And you will get a plausible interval of values for the population. You'll be like, oh, I got this. So I got that it's 53 degrees outside right now. So maybe like in the first week of January, I could say that I'm pretty confident that temperatures will be somewhere between 48 and 57. That's what I'm saying. So I go out, I get a value from a sample, and I'm like, I'm reasonably confident that from that, I can say it's somewhere between here and here usually. Garfield's, this was like super low and super high. So he's really, really confident about that. So does it make sense that the more confident you are, the wider the interval would have to be? Okay. And I'm not teaching you the maths for that today, so don't stress. We're just talking about the kind of the structure of it. Okay. So this is what you need to know about a confidence interval. The point estimate is the center. Does that make sense? If I took that random sample and today was 53 degrees, that my best estimate and the center of my guess would be 53 degrees. Okay. Okay, and then I like to call the sides of the interval the wingspan. I'm going to refer to it as wingspan because I think it makes sense to you, but that's not what it's called. It's called margin of error. So you might have heard of margin of error if you're into politics and you read about any like polls in politics. A lot of times they'll report those as some value with a margin of error plus or minus 4%, something like that. So it means it could be 4% on either side. That's exactly what this is saying. Okay. Now for my visual learners out there, I like to represent a confidence interval in a picture. So we're going to draw a picture of a confidence interval. It's very complicated. No. Okay. It's got a center. Which is a value you would get from a sample. And then the margin of error is the same distance on either side. So it has like a plus or minus value. I don't know what the middle is between -40 and 200. What is the middle between -40, 80? Yeah, 8. Okay, so Garfield's example, this would be 80 degrees, would be the center of what he said. And then his low was -40 and his high was +200. And those are even distances on both sides, so it's symmetric. And I'm gonna draw this a lot because I feel like it helps people's brains, to draw it. And, you'll see this in two different ways. So you'll see it three different ways, but one of them is stupid. Sometimes you're going to see it like this. So sometimes you'll see it like that. The point estimate is the middle plus or minus the margin of error. And sometimes you'll see it that it looks like a coordinate. But if you've taken pre-calc or calculus, it's like interval notation. So it looks like a coordinate, but the low would go here and the high would go here. Please do not put all of your preconceived math into the interval notation and think that it also, because it's parentheses, it's not equal to that value, and that's not brackets. You guys know brackets are closed and parentheses are open in math. There's none of that in statistics. These are just, don't, please let that go. It's just the low number, -40 degrees to 200. So if you see that, that's what that looks like. But don't get all into the not equal to and all that, please. If you didn't take pre-calc, you're safe from that. You don't have to worry. This is it where you might have an advantage if you did not take pre-calc or calculus. I know. You wouldn't be confused questioning the notation. That's not true. Okay. Now we're gonna do, after you set this up, this is gonna be the worst part of the whole period right here. This is the sentence that is going to require memorization. I would like you to notice, mentally prepare for the amount of lines that I have left after the colon. Do you see it? Yeah. And a lot of you guys write a lot smaller than me, so. Okay. And we're going to interpret the confidence level. We're going to make the recipe sentence here. So for those of you that like to ask me, where can I find an example of interpretation of that particular thing? This will be your spot where you're going to look all chapter. We're going to write it with blanks in there so you can change it for any context. It's going to be great. Then I'm going to show you, you get to take a break from writing, and I'm going to show you an applet, which is going to kind of visually describe what this is saying. And I'm hoping that I can have a very important keyword in there that once you ask me, like say next week at this time, what that was again, I'd be like, remember the blank. Really hope. We'll see. Okay. Be prepared to be annoyed. Here we go. Interpreting confidence level sentence. If we select many random samples of size n equals blank. This kind of sounds familiar, probably. Because we used to say like over many random samples of size. Okay, gonna pause there.
Okay.
We select many random samples of size blank. Okay, so you get a sample. And you go home and you get out your little TI 84 and you do the maths I haven't taught you yet and construct a confidence interval. And then you go back out and get another sample. And then you go back home and get out your TI 84 and do the math I haven't taught you yet, and make another confidence interval. And then wash, rinse, repeat a lot of times. Okay, can you picture that happening? So you go get a sample, do some math, go get a sample, do some math, go get a sample, do some math. That's all we've said so far. Okay. Then. Okay, and this is a very important word here. Okay. So what this is saying is about the same percent of those intervals will have the actual real proportion in that. I'm going to change the language now to my fun language, the Mrs. Talbot fun language. And you guys know the game Battleship. Okay, now I'm gonna change this to a battleship context. And I'm gonna say about 95, it's like use 95% confidence intervals most of the time. And I want you to relate that straight back to the normal curve, and being 2 standard deviations out is 95% from the empirical rule. That's where I'm getting 95% from. That is the most common one. We use 90, we use 98. You can use anything. Garfield is definitely using 100 in my joke. Okay, but I use 95 a lot because it's clean, 2 standard deviations out. Okay, that means that 95% of the intervals will be hits and 5% will be misses. Meaning 95% of them would have the actual real number in there, the population number. 5% of them wouldn't get it. Okay, now, all right, take a break. Let's go to the visual, because I have a lot of visual people, including myself. Okay, and I didn't make this, but I found this. This is a CPM one that I stole, and this is going to be my battleship situation. Can you guys find me the cut and paste, the arts and crafts piece that has a magazine recently asked a random sample? I'm gonna set this up for that because we're gonna be using that example. You don't need to cut it out right now. You can, but I'm just gonna use the numbers from it. So can you guys tell that, hold on, let me see if I can make this bigger. The sample size is 1006. Can you read that and say that, tell me that the sample size is 1006? Okay, and you guys don't know this, but the number in the middle of 0.175 and 0.225 is 0.2. Okay, you do know that, I guess. I was just thinking it was, 2 weeks after break. I'm going to set this to 0.2. And I'm just going to say a 95% confidence interval because that's what the problem said. And then I'm going to zoom this back out. Also, notice up here that it's asking me if I met the large counts condition. That's just throwing that out there, foreshadowing for later. Okay. So this is what I mean by battleship. Take a look at all of these little black lines. Okay, that first black line is a random sample. They did the math. And it's a hit because it hit the actual proportion P line. You see the vertical line going down the middle. Okay. And all of these are hits. And this guy's a miss. Why is that guy a miss? Because he's a wonky sample. Sometimes you get a wonky sample. Remember the person who had like almost all blue M&Ms? Like, that's a weird sample. Sometimes it happens. Okay, but if you do our math correctly, about 95% of these should be hits and 5% should be misses. It says right here, in my particular set of 100 samples, only 92 are hits. Should I be concerned? No, because of sampling variability, which means that if I keep going, it will converge around 95%. Should I keep going? No. Do you guys understand the concept of hit and miss from this? Let me see. Oh, now I have 200 samples and I got right to 95. Am I ever going to ask you to do 200 samples? No. Am I going to ask you to do one sample? Yeah. Okay. All right, so go ahead and set these up and then we will do the arts and crafts bit. And this part of the notes, this what it does not say part. I know there's problems in the homework that are going to ask you if you can use a confidence interval for certain things. I can't remember exactly what the homework problems say, but I know like this bit comes up in the homework. Just trying to give you a heads up. Okay. What does a confidence level not say? It does not say what the true value is. We are never 100% confident. Not even with Garfield. I know there's one of you cynical people out there who is like, well, what if it's like, the apocalypse or a meteorite hits the earth and it's above 200 degrees that particular day. I know someone out there thought that. And you're right. You're never really 100% confident. But the confidence interval doesn't say anything about like a 95% sure that I'm gonna get the temperature. I'm gonna sample and get a temperature between this and this. Not saying anything about what you're gonna do in the future. Not saying anything about individual days. It's just a range, it's a plausible range. Okay, and this one people are not gonna love, but it's not saying that there's a 95% chance that 60 is in your interval. Not saying anything about percent chance, not saying anything about probability. Confidence and probability are not the same thing. So you gotta let go of your chapter 5 when you're working on chapter 6. This is not about probability. This is about your confidence level in something. So don't say there's a 95% chance that it's gonna be between, you know, a certain thing, negative 40 degrees and 200 degrees. It doesn't work like that. Okay. Now we're gonna do the other sentence. This one is much shorter, and this one you're going to write a lot more than the other one. This is the one that you should study. Study this one. This one will come naturally. I promise. Okay. Okay. So now we're done kind of learning stuff. What we're going to do is this example with this gas in the Earth's atmosphere dealio. So we're going to go back and practice all of these things with this example. So you guys can go ahead and cut out those 2 things for today. I'm going to turn my notebook over. Some of you guys might be right in the middle of the page because you're so good at writing. And you don't take up the whole entire page. And this is where you're going to use that the high-powered calculator that you got out. It's really, I was being sarcastic. It's very easy now. No, it's not. You tell me something, I'm gonna go tell you no. Wow. Wow. Yeah.
Okay, you guys, let's finish this up. Okay. A magazine recently asked a random sample of 1,006 US adults which gas makes up most of the Earth's atmosphere. By the way, it's hilarious if you ever watch a video of people getting asked this question. Like nobody knows. Nobody knows the actual answer. I actually don't know that I would have answered it correctly before reading this statement. I think I would have said hydrogen. No, I don't know. It's really nitrogen though. Anyway, so once you get past, high school, just kind of forget about these like general education facts. I should know this. Anyway, okay. For my visual folks out there, what I'd like you to do is draw an interval. I don't care how wide you make your wingspan. I'm going to go over 3 boxes. But I think at first, this really, really helps people avoid memorization because we need to not be memorizing things right now. We need to actually understand what's happening minus note card is what I'm saying. So it's telling me this is my interval. This is the shape of every interval. The center is symmetric to the 2 ends. The low end is 0.175. And the high end is 0.225. And when it says calculate the point estimate and margin of error, it's simply asking you to find the middle and the wingspan. Does that make sense? Okay, so point estimate is just the average of these 2 numbers. Which you could probably do in your head. Also, we did it a minute ago. Okay, now there's a couple of ways to find margin of error. If you have the picture, you can just subtract between the high number and the middle, or between the middle and the low number. But what a lot of people do is instead of doing the average, they'll do high minus low divided by 2. With the picture, I think it's just easier to go 0.225 minus 0.2, 0.025. So what that's saying is the distance on the wingspan on each side is 0.025. Okay. Very, very simple math, but I want you to connect it to those vocab words. So point estimate just means the center. Margin of error just means the wingspan, so distance to the endpoints. We good? Okay. And if you draw the picture, make yourself draw the picture every time, there will not be any need to memorize. Interpret the confidence level. Okay, this guy you're going to have to memorize. If we select many random samples of size n equals 1006. Everybody good so far? Everybody see where I got the 1006 from? Right there. Okay. And construct. Okay, so I look back at my blank and it's got a percent right here. What percent confidence are we using in this problem? 95, and a lot of them are going to be 95. So we got a lot of samples. We did a lot of math. I don't know if you noticed how fast that applet worked, by the way. For 100 samples, like math for 100 different numbers is pretty great. Anyway, about 95%. "95% of the intervals will capture." It's supposed to say capture. Apparently, I have not written anything in 2 weeks. Okay, and when you hear that word capture, I want you to picture that battleship picture, like the hit or miss. So 95% of them will hit the true. Okay, and then in our recipe sentence with the blanks, we wrote parameter and context. The parameter in this case is the true proportion. So what you're going to do is find the word proportion in the problem and then copy off of the problem for the context. So the true proportion who would correctly answer. Is nitrogen lowercase? Okay. I have a habit of unnecessarily like capitalizing stuff, and mostly school subjects. Like I didn't realize like science, lowercase, math, lowercase, Spanish. I always see that capital. I don't know anyway. Okay. Okay. Two more things, so we're done. Interpret the confidence interval. This is the one that I think you're going to write so many times that you're going to not need to worry about memorizing. We are 95% confident. Did I say of or from? From. Okay. We are 95% confident that the interval from low to high, what was the low and what was the high? Mm-hmm. No, that's supposed to say the word two. Hey, but I made it that whole time without getting out the whiteout. Nice. Nice. Okay, what's next? The interval from low to high captures the true, and then same thing is here. And we're doing proportions whole chapter. So there's your big hint. Just look for the word proportion. Okay, is it say that there's a 95% chance that the true proportion is between 0.175 and 0.225? Now, remember, this is not a probability, it's your confidence level. Does it say that I'm 95% certain that the next sample I ask is going to have a number between 0.175 and 0.225? No, you can't predict the future. Dang it. Man, if we could predict the future, we could just stop this whole thing and just start making millions.
Okay. C. This one refers to monkey multiple choice. Have you ever seen a video of monkeys answering multiple choice questions? No. So they have like a big A, B, C, D, and they'll tell them to just go push one or just go touch one. They get it correct about 25% of the time just by random chance. Okay, so if people guess 4 different answer choices at random, so like monkeys walking up to an adorable giant A, B, C, or D, about 25% should get the answer correct, adorable monkeys. Okay, now that isn't say that you should judge yourself on whether or not you do well on MCQs versus what monkeys can do on MCQs. That's completely different. That's why Mr. Coyne gives 100% when people get a 0, because it's actually much harder to do terrible. Does the interval provide convincing evidence that less than 25% of adults would answer the question correctly? Okay, let's look at the numbers in the interval. Are all of the numbers in the interval less than 25%? Okay, let me go back and say what this is saying. This is saying that we're 95% confident that the actual number of people who know that it's nitrogen, I suspect of these numbers because I think it's much lower than this, but whatever. The number of people, percentage of people that actually know that it's nitrogen is somewhere between 17.5% and 22.5%. Is this convincing evidence that it's less than 25%? Yes, because everything in here is less than 25%. Where would 25% be? Like above it, right? Okay, so I like to think of it this way. Less than 25% covers the whole interval.